So hello everyone. In this lecture we are going to discuss the behavior of T flip-flop. T for toggling, and we have already discussed the toggling condition in case of JK flip-flop. So in JK flip-flop, when we have the value of J and K as 1, then it start toggling. And in case of toggling, we avoid using the level triggered flip-flop. We use S triggered flip-flop to avoid the race around condition, right? So we are assuming that when we are constructing the T flip-flop by utilizing JK flip-flop, there is no issue of race around. So let's draw the circuit diagram and truth table for the T flip-flop. So if this is the JK flip-flop and it is I am considering as negatively as triggered. So this symbol represents the as triggering and this bubble is representing negative. So this JK flip-flop is negatively as triggered. This is clock pulse, and both these J and K pins, when I'm joining, I'm saying this is, let's say, T input. This is Q state and Q bar. Now in the truth table, when the clock is 0, this T will become don't care and the previous state will be preserved. We are already aware about this. When the clock is 1 and T is 0, so when T is 0, this pin will get 0 value and this will also get 0 value. So when 00 JK will get, it will preserve the previous state. So the previous state will be preserved and that is Qn. So it will be Qn only. So that means it is working as memory. It is also working as memory here. So I'm not writing, or you can write like memory element. And here also it will work as memory. But in another case, when clock is 1 and T is getting value 1, in that case, both these pins will get value 1. And we know that in JK flip-flop, when both J and K get value 1, it will start toggling. So if earlier it was maintaining the state Qn, now we will get Qn bar or Qn complement. So this is toggling. So this is the truth table of T flip-flop. Let's draw the characteristic table and excitation table of the T flip-flop. In characteristic table, we have two things. Like first thing is clock, and we will have the value of T. Based on these two values, we will be predicting Qn plus 1. No, in that case, we should have previous state also. So that is Qn. So let's say I'm considering here Qn also. So let me wipe it, clock, and here Qn. So let's say this is Qn T. You can consider clock also. So clock, when clock will be high, then only the toggle situation will come. So you can avoid considering clock also. Okay. So let's say you are having Qn and T, and based on Qn and T, you are predicting the Qn plus 1. That is characteristic table. So when let's say Qn was 0 and T was 0, if you are not considering clock, then there will be only two rows you can construct. Or if you construct all possible 4 combinations, then also you will get only 2 types of input here. So either you will have 0 1, 1 0 and 1, right? Clock I am not considering, so I am considering in all these 4 cases clock is high only, right? Now when T is 0, so in this table, whenever we get T 0, And if you are considering clock as high, it doesn't depend on the previously generated state. So it just preserve that state, right? So it is working as memory element. So when t is 0 and clock is high, t is 0, clock is high, it will preserve previous state, and the state you are considering here as 0. So it will preserve qn and the value of qn is 0. Now when the t is 1 and clock is 1, so when clock is 1 and t is 1, it will complement the previous state. Okay, so the previous state was 0, in that case it will give you 1, right? Now when t is 0 and clock is 1, so t is 0 and clock is 1, it will give you previously generated state, so that is 1. Previous state is 1 here, so it will give you 1. When t is 1 and clock is also 1, so let me consider clock here, then you may get better clarity. So in every case I am considering clock is 1. Okay, so in every case we have considered clock is high only, and based on that we are just writing these values. Okay, so in the last case, when clock is 1, t is 1, t is 1, clock is 1, it will toggle the previous state, and the previous state was 1, it will give you 0. So this is the characteristic table of the T flip-flop. Now let's draw the excitation table. So in excitation table, we consider Qn and Qn plus 1. And based on these two values, we try to predict the value of T. So when we draw it, the excitation table, you can easily draw it. In all the cases, the clock is high only, you need to consider. I'm not writing the clock values here, right? Okay, like this, okay. Now here you get the 4 combinations, so 0 0 0 1 1 0 and 1 1. So when you have these 4 combinations, for 0 0 you consider, so when the value of qn is 0 and qn plus 1 is also 0, the t is 0 only, t is 0. When qn is 0 and qn plus 1 is 1, there is only one case here, 0 1, so the t will get value 1. Now in case it is 1 0, 1 0 means qn is 1 and qn plus 1 is 1, qn plus 1 is in this case, the last case, 1 0. In that case t will get value 1. And if both qn and qn plus 1 are 1, like this third case here if I am talking, so in this qn is also 1 and qn plus 1 is also 1, in that case t will get value 0. So this is the excitation table of T flip-flop. So with this, I'm ending this lecture. Thank you everyone for connecting.